Hi, and welcome to Gamut CG. I'm Skylar, and I've been working in the VFX and games industries for several years now, mostly in pipeline development and rigging roles. And this channel is intended for me to share some of my knowledge on challenges that I've faced, and hopefully give and provide you with solutions that might make your life a little bit easier if you're in the industry or looking to get into the industry yourself. So every time I go to a new studio, the pipelines can be similar or different to the last studio you've worked at, but they don't always support the workflow that you're used to. So instead of being slowed down by learning the new pipeline, it's good to have a few scripts that you're familiar with so you can keep productive while you're learning that new pipeline. Some of the scripts I tend to find useful are often the ones that consist of positioning objects. In this case, I'm referring to joint placement between vertices. This is a little script that is easy to incorporate into a pipeline if it doesn't already exist, and it can easily be scaled up as well to account for whatever situation you need to use it for. So I try to write it as simply as possible so it's readable, but you can always change how it works to get whatever result is going to work for you. So in this particular case, like I said, I'm talking about matching a joint to select vertices. So maybe we want to match a joint match joint to the fingers for a particular finger position or in the hand, and we want it to be positioned accordingly to the vert positions themselves. So of course, if you're doing this manually, you could easily just take the joint, you could go into snap to projected center, and you can move around that joint in the hand. It'll do a pretty good job of getting you somewhere in there, and you can move it around, put it in the thumb, maybe put it into the other finger, and it works pretty well. However, it doesn't give you the exact precision that you might want. Maybe you want it exactly in the exact center of that mesh, or you want it lined up to a specific set of edge loops. In that case, you might want to give it specific verts that are in those edge loops, especially when you're dealing with really high-res mesh. So how I do this is I'll make a function. We'll call this a joint snap. And first thing we want to do is we want to get our selection. So, and like I said, you could scale this up to add inputs if you wanted to do that instead of using selection in here, especially if you're going to add into a rig builder pipeline or something. In a case where I can see this a lot is where you're doing a component type system where maybe these joints aren't parented. If they're not parented, you'd have to get the local space position. It makes it a little bit more difficult. But in this case, we're kind of assuming this is for something like a component system where you're moving these components around, and these components will represent where the joint placement will be or for that particular section of the rig or that part of the rig. So here we get the selection, and I'll just add here to call the function joint snap. Right. So this is going to get the selection. Maybe we print it. Right, so it knows that we have this joint selected. If we select some verts in here as well, so maybe we want it to go to this knuckle, and then we select the joint. Now it's going to tell us, okay, so we've got this range of vertices in this joint, and then we want to match this joint to these vertices in this particular case. So the next thing we would want to do is we want to check that even if there is a selection. So if there is a selection, it's just not going to continue. Then the next thing we want to do is get the object type. So the reason why we want to do this is we want to tell if it's a vert or if it is a joint, and that's where it's going to go into these joint or vert lists. So now we have the object type, and we go through. So we go through each item in the selection. We're checking the object type, and then if it's a joint, we're going to add it to this joint list. If it has vertex in here, and obviously there are other ways to see if it's a vertex. You can use the OpenMy API, or you can find out the connection history. There's a bunch of ways you can find out if it's a vertex without just kind of hard coding VTX. But I just try to just make this as readable as possible. So first we want to get the mesh name to know what mesh we're dealing with, so we can rename this each individual vert. So what we want to see is we get the mesh name, we get the vert, and we want to see if this is in here, that means there's a range. If there's a colon in the middle, that means there's otherwise it's only going to select the first vert in that range, and we don't want it to do that. So what we do is we're going to go, we tell that it's a range. We get the start and the end of the range. So we're splitting it by that, getting the first part of the range, the start and the end, and then we're going to add it into this. We're going to iterate through with the start to the end, and we're going to recreate the name for each of these verts and then add them to the vert list. So now we would have every vert for this range, and then otherwise, if it's just one, we're going to add that to the index. So here, maybe let's print the vert list, and we'll print the joint list. So let's show that. Okay, so now we have the list here, the verts. It's printed there. We don't need the selection printed anymore. Okay, so we know that we have the vert list of all of these, and even though we know we have a range selected, it went through 1355, 1356, 1357. So it's got every single vert for us, and then it's got the joint that we want to match to the vertices. So that's exactly what we want. Now that we have them all in the list, we have all the data we want in the list. Now we want to get the position of all the verts in world space. So we get all the positions world space. We create a list. We have the X position, Y position, Z positions, just to make it easier. And then we have for each vert in the vert list, we're going to get the position. So we use XForm, we pass in the vert, and then we're going to query the translation in world space. And then that will give us the X position, which is, because we know this is going to return a list of X, Y, and Z, then we're going to add those positions to each of these lists. And now that we know we have all the X positions, all the Y positions, all the Z positions for every single vert in our selection, we want to make sure we get the average of those positions. So then what we do is we're just going to go, we're going to get the average. So it's a simple sum over length, sum over number of values equation. We get the X, so average X, average Y, average Z values. Then what we should get is, if we print it, we get average X, average Y, and average Z. And then we get -9 and -4.6. So it gives us the X, Y, and Z value, and these are the averages of all these vertices, so we should get somewhere in the middle. Now that we have all the average values, what we want to do is we want to get the move the joint to that average position. So here we don't need that print statement anymore. And now what we're going to do is we're going to move that joint to the average position. So for the joint in joint list, so if we wanted to do this with multiple joints, it will take the joint from the list that's selected, and it's going to add the translation. We have to give it a list, the average X, average Y, average Z in world space. And then if everything goes right, what should happen is this joint should snap into the average position there, as it did. And now that is an average position. So that's the perfect position there. Now let's see if we created another joint and we maybe zeroed out these, and then we went to this projected center. It might be a little bit harder to get into there. So you can still, if you had something, you can line it up, right? But if we had all the values for all the joints we wanted to add in, so say we wanted to put one at the fingertip, we can just select that, select this, and then run it again. We have this other joint here, and we just want to select here, maybe along there, second joint, snap it. It becomes a lot quicker if you already know the joints for particular. So you could already save out the vert positions for, say, the knuckle area, all the knuckle areas and the fingertip, or for all throughout your entire skeleton, or throughout your entire rig or the entire mesh, and save this. If you knew this topology would always be the same, especially for things like hands and feet, the certain parts of the arm, elbows, where you know where a vert position should go. If you want it to be exactly in the center like that, or even if you wanted to add an offset into this tool, you could save all those vert positions and then run through this and match all of the joints into those positions before you build a rig. And you can also use this for a control positioning too. If you had a control and you wanted to match a control to a joint or a control to a vert positions, especially if you're doing something like a face rig, where you're trying to match controls to a particular vert for like the corner of the mouth or something like that. You can find the script in the comment section below, add it to your toolbox, adjust it to your workflow, and don't forget to like and subscribe. Comment if you have any questions about this or about anything else related to VFX or games that pipeline or rigging related. I'd love to help out and be part of the community. If there's anything that you'd like to learn, please let me know. Hit the notification button so you don't miss any useful tips or tricks that I have to offer. Until next time.